Okay, I know I said learning Rust wasn't hard, then threw 2 videos at you of how memory works and how data is represented, but you got through that and I'm proud of you. Today we're on to actually writing some code. There's even some homework to look forward to. Programs are typically executed one line at a time. This is called flow, but we can alter what the next line is with control flow. This series has a free accompanying book in which you can find all the details for this tutorial. Check the description below. My name is Daniel. Welcome to Iris. There are 2 main ways of controlling flow: branching and looping. Before we get into that though, let's talk about Rust's coolest features, which will come up a lot in the future: patterns and how blocks are also expressions. Last time we talked about compound types. Tuples, structs and enums allow the construction of more complex data from less complex data. However, if we want to break the data back into its component parts, we can do that. Patterns can be used to destructure compound data like tuples fairly trivially. Destructuring with patterns also works with tuple structs. However, you need to specify the name of the struct like you're doing a weird backwards struct instantiation. The same thing also works with structs with named fields. Here we extract the struct named field straight into variables of the same name, as it's easy and the names were appropriate. However, it might be better in the context of your program to name them something else. We can rename the variables using colons, like renaming x to width and y to height. Unfortunately, you can't extract data from enums this way, as the value of an enum is one of a set of not only values but potentially subtypes or shapes or however you'd like to describe them. Take for example the humble option. How can we extract a char from an option char if we don't know whether the variable is some or none? Well, actually, we're going to answer that soon. One of my favourite features in Rust is that code blocks, that's any code between curly brackets, can be used as expressions. An expression in Rust is anything that could have a value. So for example, a plus b is an expression where we're adding a to b, which results in a value. You'll also use expressions like a equals b to compare whether the values of a and b are the same. This results in a value of true or false. Usually, you might use an expression as part of an assignment or an evaluation. For example, let C equal a plus b, or if a equals b. However, Rust allows you to use a block, code between curly brackets, as an expression, and the final value of that block can itself be an expression. In this admittedly contrived example, we create the variables a and b and add them together. Some cool things to note. A and b only exist within the code block, they're not accessible afterwards. The lines with let have semicolons. The line with the expression a plus b does not. C will be equal to the evaluation of the code block, which itself is equal to the result of a plus b. The code block which C is equal to is also terminated with a semicolon because let cannot be part of an expression. Why is this so cool? Because branches, loops and even functions all use code blocks. The most basic form of branching is the if statement. In its simplest form, it's an if followed by an expression followed by a block of code. 2 differences to most other languages: the expression being evaluated by the if is not in brackets, and code being executed must always be in a code block even if it's only one line. The expression must evaluate to a boolean, either true or false. If the expression evaluates to true, then the code in the block will be run, otherwise it won't be. For example, we could create an expression that evaluates to a boolean by comparing if 2 numbers are the same using double equals. If you want to run some code if the expression is true, but some different code if it's false, then you can extend the if with else. Here we compare if the first number is greater than the second number. You can chain if-else statements to create more complex branches. Remember though, code blocks, including those in if and else, are themselves expressions. This means they can effectively return their own values. Some important things to note. To make a code block an expression, the last line must have no semicolon. When we use let to set a value to the result of an expression, the expression must be terminated by a semicolon. All branches must evaluate to the same type, even if they don't evaluate to the same value. Doing big blocks of if, else is a mess. There is a better way of doing this, and we'll talk about that in a bit. There is another way you can branch with if that doesn't require a Boolean expression: pattern matching. Pattern matching is similar to our destructuring earlier, but now we can use it as a conditional. There are two ways to do this: if let and let else. Let's go back to that option from earlier. In the line, if let sum c equals maybe Yuki, we are pattern matching on the option. If it matches the pattern of some variable, then we extract the contents of sum into the variable. Within the block, and only within the block, the variable c has the value from inside the sum variant of the option. This may be easier to observe with our own enum type. Again, this example is contrived. There are better ways to do this. You can also do the opposite, branch if the pattern does not match using let else. The important thing to note here is that the execution cannot continue after the code block. You must exit the current flow, whether that's returning from a function or breaking from a loop. This pattern matching stuff is really handy, right? Well, the creators of Rust thought so too, so much in fact that they added a whole control flow mechanism around it. Match is a little bit like an if in that it can branch and act as an expression. However, match can do a whole lot more than if. It'll match against multiple possibilities, allows match guards for fine-grained control of pattern matching, and is exhaustive, meaning that a match must deal with every possibility. Let's look at our vector example again. First of all, you can see that this is much cleaner than having lots of if-lets. We can also use match as an expression. What happens if we add another variant to the enum though? Well, that match statement will see that not every case is handled and cause a compile error. We can deal with this by either adding the missing case or using an underscore, which is a special variable that immediately discards whatever you put into it and will match against anything. Patterns on match arms are tested from top to bottom, and you can also match on more specific patterns like values. There's one more trick up match's sleeve, which is match guards. Say we want to do something similar to the above, but instead of matching on exactly 0, we want to match on values less than 10. We can't make a match arm for every variant, but we could use a match guard, which is like a mini if statement. The most basic loop is, well, loop. When you enter a loop, the code inside it will run until it's explicitly told to stop. This might seem a bit unhelpful. Surely you never want to get trapped inside a loop forever. But actually, we often want to keep a program or process running inside a loop. You can manually exit the loop using the break keyword. Like other languages, you can simply break from a loop, but remember that blocks can be expressions, and this applies to loops too. That means we can have a loop that does some work, and once the work is done, break with the value that we want to take from the loop. In this example, we run a loop until we find some cool number. Note the use of if-let. Then break with that value. The type of found is a U64, and by breaking with that value, the type of the loop becomes a U64 too. Another useful keyword when looping is continue. Imagine you have a series of things that need to be processed, but you can skip over some of those things. Here we'll continuously get images and run a time-consuming process image function, unless the image is an SVG, in which case we can skip it. There's one more cool thing that Rust can do with loops. As with most languages, Rust of course supports nested loops, but to aid with things like break and continue, it also supports labels. Labels start with a single quote and mark the loop therefore with a colon. This very contrived example steps through a set of instructions. Check the Iris book for the code and see if you can work out what will be output. Loop is great for programs that actually do want to try to keep running forever, or perhaps have many exit conditions. We often only want to loop over something while something is true though. The while loop takes an expression that evaluates to true or false. The expression is checked at the start of each iteration through the loop. If it's true, the loop will execute. This is actually not a great way to loop over numbers. Imagine if we forgot to add to counter. Here's a different example where we call a function until we're happy with the result. What's really cool though is that you can do all the tricks we've learned above, including pattern matching with while let. While let is extremely useful, and we'll see it a lot more in the future, particularly when we get to async await. A very common reason for looping in software is because we want to loop over every item in a collection and perform the same set of instructions for each. This is where we'd use for in. For in allows you to step through an iterator or anything that implements into iterator, both of which we'll talk about in a later video. Simply put though, This lets us step over each item in a collection, stream, or series of data. Here's an example where we step over every item in an array. Another neat Rust type that works really well here is the range. We haven't specifically covered range yet, but if you've been paying close attention to the code samples throughout the last few videos, you might have spotted a few. Ranges allow you to specify a closed or half-open range of numbers. Well, actually, ranges allow you to specify a range of anything so long as it implements the traits partial EQ and partial ORed. I've never personally seen ranges used for anything except for numbers and characters, but it's worth pointing out. We'll talk more about partial EQ and partial ORed in a later video. We write ranges in the form start.end, where start is inclusive and end is exclusive. This means that 2.5 includes 2 but not 5. If you want to create a range that includes the final number, prefix that number with equals. For example, 2 ... equals 5. As mentioned, ranges can be half open, which means you can get away with specifying only the start or the end. A big warning here though, half open ranges are dangerous when it comes to for-in loops. Ranges with no start can't be used at all, and ranges with no end will continue to try to produce numbers beyond the upper limits of the type being used, at which point your program will crash. The best way to learn anything is to practice it. For this video, I'd like you to create a program called FizzBuzz. In FizzBuzz, we want to run through a series of numbers, say 1 to 100 inclusive. For each number, if the number is divisible by 3, print the word fizz. If the number is divisible by 5, print the word buzz. If the number is divisible by both 3 and 5, print FizzBuzz, otherwise just print the number. You could do this a few ways, but you'll need to loop over each number, then choose what to do with those numbers. As a starting point, you could use a range to generate each number, then use a for-in loop to get each number one at a time, and then use some if-else statements to get the output. Can you work out any other ways to do it though? Next time, we're going to look at functions. We're also going to deal with what many people consider the hardest bit of Rust to deal with: ownership, move semantics, and lifetimes. Don't panic, I hope I've got a great way to explain this one to you. If that sounds interesting, don't forget to like and subscribe. Also, don't forget to do your homework. If you have any questions about that, drop me a comment, and I'll see you next time.